This is the Unit 10 Worksheet Day 7 review for the quiz. I'm going to do selected problems here. I'm not going to do many of the first four. I'm just going to do number one. Remember, when you're given a list and you want to write the domain and range, the domain, when we have this set here, is just going to be the set of numbers. We don't write any repeats. 1, -2, 5, and 0. Those are the four x values. They do not repeat. So this is a function, right? Now we deal with the range. So I don't like to deal with the function or not until after I've dealt with the range, after I've dealt with the domain. We have the range now, so I have a 5, a 7, a 3, and then there's another 5. Remember, you do not have to write repeated values. So that is domain and range given a set of values. Moving on down to the graphs. We'll take a look at both of these. I think these are both probably good to take a look at. Remember, your domain is left to right, and then your range is bottom to top. So left to right, if you see what's going on here, this graph is going to continue going to the left forever. So that domain would be -infinity. And then to the right, if you look, I mean, think of the behavior of this graph. It's going up and to the right forever. So we would say positive infinity. This graph has no bottom. Right, that graph just keeps going down, and so we're going to say -infinity, and then it goes all the way up forever as well, so that's positive infinity. So if that graph exits the coordinate plane, you're going to be dealing with some infinities. It doesn't mean everything's going to be infinity, but you know, you're going to have some infinities to deal with. Now this graph, we see everything. Before we do that, let's talk about whether or not this is a function. Remember, when you deal with whether or not it's a function, we're just going to draw a whole bunch of vertical lines, and you could see anywhere I draw these vertical lines, my graph is only going to get intersected once. It's never going to, any vertical line is never going to hit my graph twice, so that is a function. Whereas if we go over here, I mean, pretty much every spot, there's a couple where it won't happen, but if you draw a bunch of vertical lines, you're hitting this graph twice in a lot of places, so that would be not a function. And then we're going to look, how far left is this graph going? It looks like it goes to -8. How far right? It looks like it's going to +8. So we're just going to say -8 to +8. Then the bottom of this graph is -4. To the top is +4. Those numbers don't always have to be the same. If I have an ellipse like this, you know, it looks like I'm just going to, you know, always end up with the same numbers there, but it's not giving me an ellipse. But if I trace this shape, I'll do my best to trace it here. And I like moved it over here, I could have different numbers in there for like my left, right, bottom to top. So just, you know, don't always assume that those are going to be the same. Now, evaluating given a chart, right? So they want f of -8. So I'm going to go to -8 and my f of x is at 2. When they're asking me to add, that means I'm going to go to -6 here. And I'm going to take f of x and g of x and add those together. So f of x is 3, g of x is 5, so 3 plus 5 is 8. I'm going to do the same thing for the next problem, number 11. They want f times g of 2, so I go down to 2, and I see that f of x is at 7, and g of x is at 11, and you're going to multiply those two numbers together, and you're going to get 77. The last problem asks us where we have f of x is equal to g of x. So what we're looking for is an area of the graph where those are the same value. So if you look here, I have the same value. I'm going to check. I don't see anywhere else where the numbers are the same. So this intersection occurs at 0, 6. We don't want to say it's at 6. It's at 0, 6. So that would be the point on the graph where they meet. Now using the graph, we just want to be careful on g. G is my red linear function. So I would go to -7 and follow that up to here, and it looks like we are at +10. So this is the x value is -7, the y value is 10. The operations work the same way. Now in this one, we're going to go to +1, and we're going to find g of x, which is the red function. I've got to have the 2 first, and we're going to subtract the f of x value. So again, I'm going to go to 1, and now here I got to go down to -8. So this is going to be minus -8. So it's not just 2 and -8, it's 2 minus -8, which is like +8. So when I add those together, I'll get 10. So be careful with the order, because if your order is backwards, you're going to end up with negative 10. Same kind of idea here on 19. We're going to go to 1. It has me going to the same spot, but they want f over g. So on top, I'm going to have the function f of x, which is the blue one. So you can see it's down there at negative 8. G of x is up here at positive 2. So this is negative 8 over 2. I can clean that up a little bit, and that would just be negative 4. Okay, you would end up with negative 1/4 if you had that going backward. Now, some of these other things, if you look at number 21 here, they want me to plug in negative 3 into the function h of x. So what does that mean? That means everywhere that function has an x, I'm going to plug in a negative 3. So you want to be careful here. Notice I put my parentheses in. If you get lazy with those parentheses, you're going to have a hard time here. This is going to end up being 9 plus 3 plus 9. So my answer when I evaluate that at negative 3 is 21. All right. The operations work the same way. You got to be careful what you're doing. Here, they want me, for 23, they want me to do g minus f of x. Now, what is g? G is the square root of 3x. What is f of x? Well, I'm going to subtract negative 5x plus 3. And on this one, I want to combine like terms where I can. I'm not plugging in a number. So this is going to look really odd, but we're going to end up with positive 5x plus 3 plus root 3x. The order isn't really that important here. You're just combining those things. Oops. And I should fix my sign here. That should be a minus 3 because we're subtracting, right? This is like distributing a negative 1. So combine like terms where you can. On 25, we're going to do f times g. So that is going to be f, which is negative 5x plus 3. And we're going to multiply that by g, which is root 3x. And we got to think back to our rules with multiplying radicals, right? So inside times inside, outside times outside. So we're going to combine those, and then I'll get 3 root 3x. Those coefficients are not like terms, so you're just done there. That's the best we can do there. And then for f plus h of 1, we're going to evaluate those at those points. So f is negative 5x plus 3. So negative 5 times 1 plus 3. That's going to give me negative 2. And then h of x is that quadratic one, right? So I'm going to go x squared minus x plus 9, I believe that was. Yeah, that was plus 9. And we're going to end up getting 1 minus 1, which is 0. So this is going to end up being 9. And then you're just going to take negative 2, add 9, and your answer is 7. So you plug the same number into both, and then take the result and just do whatever they ask you to do. Sometimes you add, sometimes you subtract, multiply, divide. That's all that we need to do there. Okay. Thanks for watching the video. Good luck on the quiz.